Okay, let's dive into these sources. You might think calculus, especially integration, just stays in the classroom, right? Or maybe complex physics.
Yeah, you really would. But, these sources, they reveal this, this unexpected connection
A connection between what?
between calculus, that very mathematical tool, and something incredibly down to earth, animal husbandry.
Animal husbandry.
Mhm.
Seriously, like raising farm animals. That sounds worlds away from an integral sign.
It does seem like it, doesn't it? But the sources are quite specific.
Okay, so what's the specific application they found?
It's about using integration specifically to calculate the total amount of livestock feed needed.
Total feed.
Right. Across different kinds of agricultural pastures and tracked over a whole month.
Wow. Okay, that's genuinely interesting. So it's not just theory. Someone might actually be using calculus to work out how much food their cows or sheep need.
Exactly. And considering, that different fields probably offer different nutrition.
Right. Not all grass is the same.
Yes.
And maybe needs change day to day.
Precisely. The sources flag this as a really concrete, real-world example. Useful, they say, for students learning differentiation and integration.
Kind of takes the math off the page and puts it, well, literally in the field.
You could say that, yeah.
So, okay, help me understand why integration. Why not just, I don't know, estimate? Or maybe multiply an average daily feed amount by the number of animals in days.
Well, that's the crux of it, isn't it? That's what these sources really get at. Think about it. Feed needs aren't static.
No.
The quality of one pasture might be great, another less so. Maybe animals get moved halfway through the month.
All right.
So the rate they eat, or the rate the pasture provides food, it's probably changing constantly during that month, both across different areas and over time.
Gotcha. So you can't just take one single number like feed per day and multiply. The rate itself is shifting around.
Exactly that. And integration is the mathematical technique built precisely for summing things up when the rate of change isn't constant.
When it varies over whatever interval you're looking at.
Right. In this case, the interval is partly space, different pasture types, and partly time, the duration of the month. Integration lets you get a precise total because it accounts for all those little variations along the way.
So it's like adding up an almost infinite number of tiny slices of feed
Mhm.
needed right now, where right now keeps changing based on location or time.
That's a good way to think about it, yeah.
Yeah.
It captures that dynamic reality.
Which makes a lot more sense for farming than a simple flat rate.
It definitely provides a much more accurate picture than just averaging. It helps manage resources better, avoid underfeeding, avoid overfeeding.
It's really cool seeing these fundamental math ideas popping up in such practical fields. Okay, so wrapping this up,
Hmm.
the big takeaway from these sources seems clear. Integration isn't just abstract math homework.
Yeah.
It's a real tool.
A tool used in places like animal husbandry.
Yeah, specifically for figuring out tricky, varying things like total feed needs across different conditions and over time.
Absolutely. And, thinking about that specific use, here's something for you to consider.
Yeah.
Why integration?
Huh.
Why is adding up something that changes continuously over time or space fundamentally different than just simple multiplication, like rate times time?
Mm-hmm.
What is it about the real world, whether it's feed on a farm or something else entirely, that integration captures, but that simple calculation just misses? Something to chew on.